calculate the exact bounded area between the curves given by f of x equals x squared plus 6 and g of x equals x plus 62, which I've already graphed on the left. Notice the bounded area is this area here. It's important that we always graph the two functions when determining bounded area, because when we set up the definite integral that will give us the bounded area, the integrand function, as we can see below, is always the top function minus the bottom function, which means in our case, the integrand function is going to be the linear function g of x minus the quadratic function f of x. We also need to determine the x-coordinates of the points of intersection to determine the limits of integration with respect to x. In this case, we can see from the graph, the x-coordinate of the point of intersection on the left is x equals -7. On the right is x equals +8. This interval will be the interval of integration. If we didn't have a graph to determine these x values, we can always find them by setting the two functions equal to each other and solving for x. And I do also want to show this. Setting the two functions equal to each other, we have the equation x squared plus 6 equals x plus 62. Let's set the right side equal to 0 by subtracting x on both sides, as well as subtracting 62. This gives us x squared minus x, and then 6 minus 62 is -56, giving us minus 56 equals 0. Let's solve by factoring. The factors of x squared are x and x. The factors of -56 that add to -1 are -8 and +7. The left side equals 0 when x equals +8, or x equals -7, which we can verify from the graph. And now we have all the information to set up the definite integral that will determine the bounded area. The bounded area A equals the definite integral from -7 to +8 of, again, the integrated function is going to be the linear function minus the quadratic function, which is the quantity x plus 62 minus the quantity x squared plus 6, integrated with respect to x. Let's simplify the integrand function. Let's write the terms in descending order. We have -x squared plus x, and then 62 minus 6 is +56, giving us +56. And now let's find the antiderivative. Integrating, we have -x cubed divided by 3, or -1/3 x cubed, plus x squared divided by 2, or plus 1/2 x squared, plus 56x. And now we determine big F of 8 minus big F of -7. Substituting 8 for x, we have -1/3 times the cube of 8 plus 1/2 times the square of 8 plus 56 times 8 minus, to determine big F of -7, we now substitute -7 for x, which gives us -1/3 times the cube of -7 plus 1/2 times the square of -7 plus 56 times -7. I've already evaluated this expression to save some time. Big F of 8, or this expression, equals 928 divided by 3 minus big F of -7, or this expression, is -1519 divided by 6. And simplifying, and this simplifies to 1125 divided by 2. Because this does represent area, we could label this as square units. This is the exact value of the bounded area. I hope you found this helpful.